Hey everyone, it's Timmy Gobbles. Today I'm going to be showing off this little maze generator I made in Godot. So here's kind of the basic simple game. You're a little mouse and you get to move around and you try to get a piece of cheese at the end of the maze. And there's a time limit that goes up as the maze increases in difficulty. And by difficulty I just mean the size of the maze, not like the complexity of it. And eventually the maze gets really stupid and then you run out of time and you lose and it starts over. So today I'm just going to be talking about how I generate the maze. So this maze generation algorithm is called the walk around until you can't go anywhere and then go backwards a step and try again. So you progress through and add successive steps until you can't go anymore, and then afterwards you take a step back and try to see if you can add points. So to give a more in-depth idea, so here's a point. So I look at the 4 adjacent points and see and add 1 if I can. If I can't, then I go back a step. And then so here we go back a step, here we can add 1. Gotta go back a step, go back a step, add a point, and back a step. And we're all out of points. The queue's gone, and we're done generating the maze. So what do we need for this maze class? So I need probably like a width, a height, a start point, and an end point. Those we won't know till later. Also, I need to be able to store data in a grid. So here, if we have a grid, it's 4 wide by 3 tall, and we can think of the register numbers of in each of the boxes laid out like this. So we count from left to right and then top to bottom. So there's 12 total registers in this grid. I know I put 13 in this array at the bottom, but don't look at that. And so if we know the width and we know the height, then we can take a vector and find the register of the data that belongs in. So you take the width of the vector plus the width of the grid times the height of the vector, and that'll return which box of data you're looking at. So let's go ahead and make that grid class. So we need to know the width of the grid, the height of the grid, and needs like a list of contents. And for this one, I'm just going to use integers, but you can really put anything in each of the grid points. You could have booleans or another array. I don't know, just a whole bunch of junk. So then let's make an initializer. So the list size is going to be the width times the height. So that's pretty easy. And we want to be able to set a value of the list at the appropriate point based on a vector. And we also want to be able to get that value. So if I pass a vector in, I want to know what the value in that list is. And I was thinking it'd be cool if I could like recycle it. Recycle function. Maybe that comes up later. Anyways, so our maze needs a member of this grid class to be able to keep track of that kind of info. All right, so yeah, here comes that recycle thing. So I need to clear that list, or really just fill it with zeros, like fill it with a default value. I need to update the width and the height. So now that grid's done, let's go ahead and make an initializer for the maze class. So that's just going to be a width and a height. And once we've done that, we can go ahead and initialize the grid using the grid initializer, or what do people call that? Constructor? I don't know. Maybe let's not do that yet. Yeah, so when we make a maze, let's go ahead and initialize it if one doesn't exist. And if one does exist, we'll use that recycle function. All right, so what do we need to keep track of for the maze? We need the list of points that are like walkable, and we need a queue. And those will be pretty closely related until we start taking steps backwards. I was thinking about having little catch statements in grid, And then I decided that I'll just try to be a little more rigorous with indices and not passing values that I shouldn't be. But if you're lazy, you can always just put in an if statement to get rid of things that you shouldn't be passing through. Okay, and we need to add an initial point. So let's go ahead and just pick a random point that's inside the maze, excluding the boundaries. And we can use random iRange for that. And since we have a start point, we should put it in the list of points and the queue. And we should make sure we assign it to start. Now, I want to be looking at the neighbors of a point in the queue. So like left, right, up, and down. So if green is a point, then blue is going to be its neighbors. And those are going to be the potential next points that we add into our set of maze points. Oh, and I also need to take start and add a value in that grid for it, which means that I need to fix that set function to actually pass a value and set it, because I forgot to do that. Okay, so now we want to loop over until our queue is empty. And each time we do an iteration of the loop, we need to look at those neighbors. So let's go ahead and make an array of just the upright, left, down. Is that all of them? Yeah, it's all four. I'm gonna go ahead and shuffle it each iteration, and then we're going to loop over each of those directions. And we're going to take the last point in our queue and add those directions to it to get a potential new point that we're going to call next. Now, next isn't always going to be something we want to add, so we need to do some checks to make sure that it's appropriate. So we need to make sure that it doesn't have a value in that grid, and if it does, we'll just go on to the next one. And we also need to make sure it's in the bounds of the rectangle, like based on the width and the height. Like we don't want to be passing points to the grid function that don't exist. All right, and here's some other checks we need to make. We need to make sure that that next point doesn't have any neighbors that are already part of the maze, because otherwise it'll end up making loops in our maze. But we need to ignore the previous points in the path that we're on. So green and purple are fine. Green's the current point, blue's next, and then purple is like where green came from. So we need to check these, and we also need to check these corners right here and here. But we don't want to check the purple, the green, or the other side of the green. And the reason why we don't care about the point right below green is because when we added green, that point would have already been checked. So we don't need to worry about that. Technically, we don't need to check the point above and below blue, but later on, that's going to come into play. Okay, so we need to iterate over those 5 different positions and check to see if they have a value in grid. So if we take the direction we took to get to next and add it again, that'll go in the direction we want to go, and then we can take the orthogonal direction of that by flipping the y and the x value. So that's that orth vector, and that by combining those, we're going to get a list of 5 different points that we can check. And so those vectors are what I'm calling neighbor. So I'm going to set up this bool. It assumes that next is good, but once we find out that it's bad, we're going to break out of this loop of neighbors, and we're done with next. We move on. Okay, so then we need to add next if it was good, and if not, we can just ignore it and move on. So in order to add it, we need to add it to points, we need to add it to the end of the queue, and we need to add a value to grid by giving its grid value 1 plus the previous points value. That's going to help us find the end of the maze, because we're going to take the point in grid with the highest value, and that's going to have the highest step count from the start. And if we added a point, we want a Boolean to keep track of that, to know whether or not we need to take a step back. Okay, so if we added a point, we need to check whether or not it becomes the end of the maze. So that way we don't have to do it at the end. So we can do that by checking the endpoint. And let's go ahead and do this inside the very, very nested loop. So we're going to see the value of the endpoint and the value of next. And if next is bigger, then it becomes the new endpoint. Okay, so we're ready to test this algorithm. So I have like a little test scene with a tile map and a camera. And I need to make a new maze and then have it generate a maze and then use that grid to decide which tiles of the tile map get filled in, which don't. So walls are going to get filled in and walkable points are going to be left blank. So if the grid has a value, then it's walkable, right? Because it starts at 1 and it counts upwards. But if it's a wall, it's going to be 0. Okay, so here's an issue. Okay, so it's an out of bounds error. When I generate these neighbors, I'm not checking whether or not they are in the bounds of the maze. So I need to go ahead and ignore ones that are out of bounds so that they don't end up passing a out of bounds error. Okay, so this looks wrong. So if I get rid of my old example, yeah, so there's not enough walls. So what's going on here? Okay, so Orth was flipping next, and I want it to be flipping direction. So I want direction.y, comma, direction.x. Okay, and there's our maze. Nice. And if we close and run it, it keeps making the maze. I'm going to go ahead and add some input so that I can generate new mazes more quickly. So in this project, I already had like arrow keys and I think spacebar set up as inputs. And I probably want a function to call when I want to make a new maze. So I'm gonna have this maze and set maze. Oh, make and set maze. Can't read, my eyes are going bad. And I want to be able to make bigger and smaller mazes, so I'm going to add a little bit of zoom to the camera. Do I have the camera? Yeah, I have the camera as an export variable, so it's easy to affect. Alright, and I want to clear the old maze when I make a new one, so I'll just do tilemap.clear. I could have been keeping the maze variable and not making a new one every time, but oops. Alright, I'll go ahead and make the maze size a variable so that it's easier to change. I forgot to include the maze size in when I iterate over the grid. Dang it. Okay, and here we have a pretty big maze, and it generates pretty quickly. And I didn't like the zoom, so I'll edit that. And I'll go ahead and make the maze 16 by 9 so that it kind of fits the screen better. Alright, cool. And there's a pretty big maze with just a whole lot of junk, huh? So let's go ahead and make spacebar and make a new maze. It'll be easier than opening this project over and over again. So yeah, it generates really quickly. Here's me just mashing the spacebar button. The video is sped up ×4, but like it's a pretty quick algorithm. Blech. And so kind of to demonstrate how the algorithm is working, I'm going to go ahead and take those points and add them to the tile map 1 by 1 instead of all at once. And so that'll kind of show how it's making the path. So if we make those points an output of the make maze function and then keep them in an array in test2, is that test2d? Yeah, test2d. Then we can use process to take the next point and add it to, well, actually we're going to carve it out. So if we fill the tile map with walls, we can carve out empty spaces one by one. And this doesn't look right, does it? It has a bunch of loose points. What's going on here? Oh, I need to reverse it because I'm popping it back. I wanted to pop it back because when you pop it front, it has to like re-index all the points. And there's quite a few points here. So there we go. So you can see it. It draws a really long path. And then when that path terminates, it goes backwards and appends new paths. Next is, where does the mouse go and where does the cheese go? I decided to put the mouse at the start and the cheese at the end. So remember, start is just a random point in the maze that we start doing the walk at. And end is the point in the grid with the highest value. So each time there's a step taken, 1 is added to the next step's value inside of grid. And every time we add a new point, we check to make sure that it's whether or not its grid value is higher than ends. Okay, so there we go. So the mouse and the cheese seem to be spawning correctly. Now this isn't the longest path in the maze, because you could imagine when you start doing your walk, if there was some space to go backwards a little bit, you could have carved a longer path. So it's not like a maximum path for the given maze size. It's just the longest distance from the starting point. I kind of tried to play around with the background color. I am not like a good color person. Don't let me paint your house. So I didn't like that greenish color. I didn't like this brownish color. Oh, another thing I was going to try. Okay, so instead of checking those corners for neighbors, I'm going to go ahead and ignore those. And you get a little more out of the maze because it's not as restrictive. Let's go ahead and try a purple background, maybe. That's kind of better. It's still awful. So yeah, getting direction plus orth and direction minus orth out of the neighbor's array makes that tiny change. Alright, and I'll go back to drawing the path so you can see it drawing from the mouse to the cheese and then filling in the rest of the maze. Typically, well, I guess always, the end isn't going to be the last point added to the maze. I had another idea. So I was shuffling the directions for the next point every loop, but we can actually add like a little step count and shuffle it not every step. So that'll make like a less diagonally maze. But if we take too many steps between shuffles, we're gonna get these very linear mazes, which aren't as exciting. So I think I found 5 to be pretty good. I think here's at 100. This is just too much. It always goes horizontal or vertically. Because there's even a chance for it to not end up, you know, if it shuffles and you end up with the same arrangement, then it's going the same direction again, or it's favoring the same direction. Like if it can go left, it'll go left, if left is the first point in those directions. But it's just another parameter you can play with. But I found 5 to be pretty good. I think this is with 5. And you still get some straight paths, but it's not too bad. And there's another thing we can do. Instead of shuffling it, we can do reverse. So think about shuffle is gonna randomly rearrange those 4 directions. But if we reverse it, it was ordered as up, down, left, right. So if you reverse it, it's gonna check left, right before it checks up, down. So that kind of worked pretty well too. But it did have, since how often it reverses, you end up with some repeating patterns sometimes. So then I thought, okay, I'll just shuffle it, or sorry, I'll reverse it every 5 steps. And then after like 20 or so, I'll shuffle it. And that came out pretty decent too. Either way, I think shuffling it every step is a little too much because you end up with a lot of diagonals and it makes it kind of annoying to traverse the maze. But not shuffling it was too regular. And that's it for this video. Have a good one.